Welcome to TartleCast with your hosts Alexander McKegg and Jason Rigby, where humanity steps into the future and source data defines the path.
You're wearing a Whoop band?
Whoop, there it is.
And Whoop, there it is. Joke, again, same joke, 2 episodes in a row.
I need to come with some new material. Sorry. Yeah, I will. I'm going to work on it.
Tonight, I want you to think about it.
My materials is almost as bad as my presentations. I like my B stuff in there, though.
No, listen, I like the V stuff.
So this was funny. So I did a marketing presentation, and for Tartle, I love to be real personal with people. And so getting my brain, getting all of this down into a presentation to make it make sense.
Yeah.
I can do it speaking I can do it speaking.
You can speak it to me, yeah.
Yeah, I can take some of your information, and you guys should listen to Higher Density Living plug. I can take your information and put it down into that level, but to actually like type something out and get it written. Yeah. I can do audio. I speak that way, you know. But I felt your
ideas everywhere. I'm like, where did the continuity go in this?
Could you imagine? No, this is what you think. This is what I was thinking when you told me that. Can you imagine if I've prefaced all of that. And you know all of that.
I do.
So could you imagine
somebody that has no
idea and then looking at that? They'd be like, 2 + 2 is you're saying it's equaling 5, Jason?
That doesn't make any sense.
Yes.
Yeah.
Exactly.
No, that's what I mean. So that's, just a little edit, is going to be required.
This is how we do Tartle business from now on.
This is
on the camera.
We're going to tell everybody about the mistakes.
Everybody's coming on here because the title's going to talk about Internet of Things. Yeah. And then they're going to be like, they have just a little business meeting.
They'll learn about our imperfections.
Yes. I love it. That's what I like.
It's all growth.
We're human.
Yeah.
That's what Tartle's about.
Yeah.
That's why we have data, is because of imperfections.
That's precisely correct. And we can measure
philosophical.
those. I like that.
So get into IoT and Whoop.
Yeah. So IoT means Internet of Things.
Right.
What it's talking about is all these devices now, because wireless card chipsets have become cheaper. Bluetooth technology is cheaper. The availability for smaller devices to connect themselves to the internet when they otherwise didn't have the ability to do so, they were quite static, now become more dynamic, and we can wear them and we can integrate them into all these different things. Like, for instance, so this band right here collects about 128 megabytes a day, I believe. Right. Somewhere around there. It collects more heart rate data than anything else, right? It's got my respiratory rates. It's got the variance of my heart rate, so it's like testing the electrical signals. And that is interesting because this data is not only well connected now, but now it's pulling in huge troughs of information. So the question is, what are we going to do with all these devices that have become more interconnected, right? As more things come online, like even the hot lamps we have on us right now for this filming, those probably one day will be an IoT device, right? With some sort of sensor on it.
Yes.
I've been
hooked to the cameras and then watching, to see if it aligns with the blue screen and so forth.
And I've been to some smart factories. I did quite a good chunk of work, and I'm not going to mention their name. I don't know if it's fair to do that to them, with a couple of the leaders in Massachusetts, especially around like the Newton area with like outfitting smart factories. And it was amazing to see the sensor readouts on everything. Like you almost become inundated. It's like, it's almost too much to handle.
Right.
Where you're like, wow, that's a massive output. So then that begs the next question. If we're absorbing all this data right here on like your band and mine at the same time, what does that structure look like? How do we read that structure? How do we know what to properly interpret from it?
Yes.
So why don't you walk us through this article you have? And we can talk
like
about
my
that.
Presentation. We're getting all this absorption of data from a big factory.
It's just absorbing it. Now we got to put
it now, just like what you said, that's what I'm going to do.
Make sense.
Yes. Have it to make sense.
I
love it. So the artificial intelligence and big data analytics and IoT market for data capture, information, and decision support services.
They got to simplify that.
It's a big report from 2020 to 2025.
Okay.
And so we're going to see a lot of different things. So this report evaluates various AI technologies, their use relative to analytic solutions within this huge, rapidly growing enterprise industrial data arena. I mean, this is, and we're going to get into exactly how much, but like you said, Internet of Things, you have consumer data, you have enterprise data, you have industrial data, and you have government market segments.
Correct.
And each of them have their unique needs in terms of infrastructure, devices, systems, and processes.
So everybody has their own way of how they want to read and interpret things. And everybody has their own way of speaking. Everybody's got their own language, essentially. Not everyone's speaking English. So then how do you communicate value properly across multiple languages and multiple needs?
Yes.
That's what they're saying. So if this data is spitting out multiple languages and people need it in different formats, how do we effectively stitch that all together? How do we make sense of that?
Well, and one of the problems that they said is that, like you said, it's just producing mass amounts of data and it's all unstructured.
Yeah, it's unstructured. I mean, maybe it's just sitting in, one column on this massive CSV file, comma separated value file, something you pull into like Excel, but there's 10,000 rows of it, right? And it's like, how do you manipulate that effectively? Even from your own understanding with whatever key markers are in that data, right? What column should it be in, or what type of heading? Is this something that can be visual? Is this something that's more that belongs on an axis, right? To just say like, okay, or is this something that should like sit in the legend to describe it? That is going to, fall back on the algorithms that machine learning is going to be programmed with to actually take this unstructured information, the swaths of it, and then create some sort of understanding from it. So it's like, okay, I'm going to say I want it in English and I want it to tell me about fire safety.
Right.
And I'm talking about government bus lines.
Right.
It's pulling out the sensor data. Okay, great. Well, the machine learning model understands your parameters ahead of time. So it'll take all that data, scan through it, pull out the key markers for what you need, and then give you some sort of readable format or visual so you can understand what's going on.
Yeah, and the author of this article from researchermarkets.com, give him credit, from Dublin, he said that he sees three different types of IoT data. So I want you to speak to this: the raw, the untouched and unstructured, the meta, the data about data.
Correct.
And then number three, the transform value-added data.
Okay, cool. So
this is going to go right into target.
So the raw data, okay, is something that this band right here is reading.
Right.
It's reading raw heart rate, raw quantitative stuff. Essentially, it's meaningless numbers.
Right.
Okay, great. But it's ingesting it. The sensor is picking up, the sensor is doing its job, and it's taking its binary 0 or 1, and it's like triggers on, triggers off. Okay, that's a value.
Right.
And it's going to record that. That's category number one. Number two is?
Meta, data about data.
Data about data, okay? So now that I have this data instituted off my IoT band, my device or my sensor, well, now I want to see, well, what can I pull from it? So say, for instance, a photo or like our phone. We talked about this before. You take a picture.
Right.
Well, the picture is going to have geolocation data in it.
Right.
It's going to have the time. It's going to have the date. And possibly it's going to have the people that are in it if it's smart enough, right? That's going to be the metadata that sits inside of it. It's almost descriptive data about data.
Right.
And then the third one is?
It's transform value-added data.
It's transform value-added data. So after you've collected this data, the raw data, and you have the metadata about that data, right? It's categories, you know what should be applied to it. Now we can transform, we can manipulate it into some sort of visual or output that is readable and understandable for us to make decisions on.
Yeah, and that's what they're wanting to use. The articles that they're wanting to use artificial intelligence to take those three types of data and then be able to create the value in that data.
Yeah, you create the value in it. It's just, when we say artificial intelligence, how do we efficiently manipulate data faster than a person would going on doing pivot tables on Excel?
Yeah, and what they were talking about is the ability to capture streaming data, determine valuable attributes, and make decisions in real time.
Yeah, so that's important. So say I run a gas pipeline company, and I have a bunch of sensors in all my pipes measuring pressures, temperature, flow rates, you name it.
Right.
So what I would want to know is if I'm pulling things down real time and that data immediately gets pumped into the algorithm of the machine learning, structured or unstructured, it will automatically be able to pick up and notify me if there's an issue or a leak in one of the pipes, or if there's an overbuilt of pressure, right? All those different things can come into play, and then I can create immediate actionable items or insights off of what's going on.
Yeah, I saw it was really neat. I saw these drones following, this was on television. I didn't see this personally, but I saw these drones following.
So you meta viewed it.
Yes, I meta viewed it. Yes, there we go. So I meta viewed these drones on either side of a train, and they were flying right alongside the train.
Okay.
And their cameras were viewing how the train hits the track. And then they were taking that video footage and then seeing where weaknesses were on the tracks and where they need to fix it.
Yes.
Where it would take people to go look at the tracks. How long would that take compared to?
It takes a while. So I've actually seen the stuff you see in your life.
Yes.
I've actually worked in large transit systems. So you'll find pitting on the tracks, areas of extra wear, especially on corners or things of that nature, or it corrodes early. You have to go actually and check that surface. Because if there's an excess of shearing on that surface or we lose contact, there's an inefficiency, there's a slip that you might find in that transportation. And that's a cost over time.
Yes.
Whether it's a safety cost or an economic cost, right? Because now my wheels have, they've worn down too much and the tracks are worn down, or there was a crash and we got to pay for all this stuff.
Right.
So it's better we view it ahead of time, analyze it, and fix it. And so, I've seen,
because a drone would be an IoT.
A drone is an IoT. It's flying around. It's internet connected. After it takes the data and the metadata, so it's filming and it's recording data with it, it can then take that and then put it into a system, and that can be analyzed at different levels on the track, right? But the interesting part, wait a minute, now I'm lost. Oh yeah, the interesting part is that when they rebuild tracks, they usually have a guy that goes out there with this machine, 2 guys, and it has a whole stockpile of fresh track, and they'll just reset the whole thing.
Right.
Because frankly, that's less of a risk for them. But if you can find an efficient way just to change one small piece of track,
yes,
these things weigh a lot.
Yes.
They're very heavy, even for one piece of track. It's a lot of iron. So in their mind, they're like, let's just swap it all out. But if you can just grab one, analyze that area, pull up the spikes and replace it with the big metal machine that does it automatically. Super cool to watch, by the way. That's just a more efficient process for them.
No, yeah. So that to me shows how IoT devices can give a company cost savings with efficiency.
It's essentially a cost savings.
Yes.
That's all it is. We'll invest a little bit more in this, machine learning plus the IoT device, and it will give us enough of a cost savings so that we don't have to have guys out there on the tracks as much, not as long.
And I like I like the idea of it giving real time data. We're not looking at something that is happening in the past.
No, because and we talk about this with Turtle, right?
Right.
The data is real time. People are updating this constantly. It's pulling down APIs from integrated systems constantly. And if you want to subscribe to those data sets, when someone's going to take a left-hand turn.
Yes.
When they're going to change their lipstick color. You know what they're going to eat in the next 5 minutes, but you're not going to look at the past and assume that they're going to do the same thing in the future. What a waste. Why guess?
You know what assume does.
Yeah, we all know what assuming does.
Yeah, so why are we? So I thought this was interesting. So this is just AI with IoT. Mm-hmm. Global market for AI and big data and IoT as a whole will exceed $26 billion by 2025.
Okay.
Embedded AI in support of IoT things objects will reach 5.7 billion.
Yeah, so what they're saying is, we have the onset of, sensor technology, IoT. Okay, and it's connected to the internet. Now, why don't we just put the machine learning directly into that device? So rather than just having to go through the process of pumping out the raw data, have it analyzed on the device immediately and just send out the answer.
Yeah, and they were talking about that collaborative robot growth will be at 42.5%.
Yeah, no.
By 2025.
Robots are cool. I was...
so 42% by 2025, that's a lot.
There's a gentleman here over here in Albuquerque.
Right.
That when I met him, and he's designing robots. He's designing robots to actually paint.
Mm.
So painters unions, I don't know if you know much about them. They're the highest paid union workers. So if you run a large construction operation, you'd be like, yeah, I'll invest in the robots. And it was really cool to actually watch. They have perfect coverage and pressure the entire time.
Oh, of course. Yeah.
I was watching the robot just paint the room. I'm like, I'll give it to you. That's pretty cool to watch.
Yeah, I don't know. And I may have shared this story with you before, but how Mazda did their painting, the car manufacturer Mazda. I thought it was really neat in Hiroshima.
You might have.
Yeah, where they took their senior painters that had painted over 30 plus years.
Oh yeah, to program
they put the
machines.
sensors.
Yeah, I love that.
They put the sensors on their hands and then followed how they did. And then they taught the robots how to paint exactly like that. So when you can watch them. So instead of just going, they're actually moving around just like how that master painter would do. Yeah.
It's super cool.
But I think that's a prime example of looking and seeing. And each of these robots, of course, are exhibiting data.
Every single one of them.
Exhibiting data out too.
Yeah. Anytime there's a movement of the machine, there's some sort of programmable interface. There's an output that comes with it. It has to. Anything in a computer is input output.
Yeah, and they're saying autonomous weapon systems and AI and military robotics will grow 40%.
Of course it will, because the budget's so large for it.
Right.
And that's going to also be dependent on the political party that comes in. There's a ton of things that play into that.
And then finally, there's going to be...
But what's the point of the friggin' weapon? Who cares?
Yeah.
Who cares if you put a smart device on a missile? You're just going to blow it up. What a waste. Don't put the money into that.
Yeah, top 3 segments will be number 1, data mining and automation. Number 2, automated planning, monitoring, and scheduling. And number 3, data storage and customer intelligence.
Yeah. People, where's the data going to sit? How do we get it out of there? How do we get it to move?
Right.
And then what is it going to tell us about human beings? It's everything that Turtle does right now.
Yes, exactly. That's what.
Why do I got to get?
I thought I'd tee you up with this.
Why do I need an AI algorithm to find out all this stuff? I can just go ask somebody. Duh.
Yeah, exactly. Duh.
Yeah, we're gonna end that on duh, like Homer Simpson. Duh.
Sign up for Turtle.
Yeah, sign up for Turtle. TARTLE.co. Thank you, everybody.
Yes.
Thank you for listening to TartleCast with your hosts Alexander McKegg and Jason Rigby, where humanity steps into the future and source data defines the path. What's your data worth?